response on dispatch response. We have several SMUR in intensive care unit in each department. So we have about 102 SAMU in France, 428 SMUR on 728 MyQ. Most of them are vehicle, and some of them are helicopters. The SAMU is a call center. It's a medical call and dispatch center with physician and several operators. We determine the degree of emergency. We give an immediate and appropriate response adapted to each case. First, a simple advice, which is free for the patient and for the national system. The visit of an emergency GP at home, a simple ambulance, which is sent to the
Recording
patient.
in progress.
Okay. A simple ambulance which is sent to take the patient back to the emergency department, rescue team, firefighter, and a mobile intensive care unit with a physician. It's a more intensive response. We communicate continuously with the team, and we select the most appropriated and available resource hospital for admission of the patient. And we organize the transport, either transport by MyQ or transport by rescuer or transport by ambulance, or sometime after intervention of the MyQ, the patient stay at home because he don't need to go to the hospital. The SMUR is a mobile intensive care unit. We have a medical team providing sophisticated care. We have a physician. Most of them now are emergency physician, but before we have anesthesiologist on this team, a nurse or anesthetic nurse, and a driver trained as EMT. And we also have pilot for helicopter teams. We have equipment for diagnosis, treatment of monitoring of patient, and we care for any vital distress, cardiac arrest, major trauma, but any kind of vital distress, respiratory, myocardial infarction, stroke, delivery, and poisoning. And in case of suspicion of vital distress, we send a MyQ, and if not necessary, the patient stay at home and go to the hospital with a simple ambulance. So it's a visit at home for evaluation of the patient and care, and after, if necessary, only the patient go to the hospital. And this team obviously could provide sophisticated care on scene and during transport, including ALS and ACLS process. Disaster medicine is now an optional course in France with a theoretical courses on several weeks on major exercise simulating a mass casualty incident. Now, disaster medicine is taught during the emergency medical cursus specialty. Emergency medicine is a full specialty since 5 years in France. We have a dedicated society, the French Society of Disaster Medicine, SFMC, and we have more than 40 years of experience of disaster medicine in France, technological accident, hazard from factory explosion, train accident, natural disaster, Haiti earthquake. Some teams come from France to Haiti, terrorist attack, obviously, and pandemics such as COVID. Some slides, some picture. You can see on this picture, for example, here a French team on Haiti. Here a train accident near Villejust. It's Bretigny-sur-Orge in 2013. Here's a factory explosion in Toulouse 22 years ago in 2001. Here's a terrorist attack in Paris, and here's the COVID. We have transported many patients by train, by high-speed train, between different areas in France 2 years ago. The challenge of major catastrophic accident is to care for simultaneously many victims, and we have much more victims than the immediately available resources. We have many casualties of varying severity, which imply we have to perform triage. We have eventually many different sites, for example, the multiple terrorist attack in Paris. We have sometimes difficult access on transport, difficult access because of earthquake, or difficult access because of terrorist attack on the hostage taking. And we have also the involvement of many different agencies, firefighter, rescuer, medical team, Red Cross, and so on, police. So it's very important to coordinate all the intervenants. So this area of catastrophic accident is an immense field for the development of new technology tools. The new technology, it's an increasingly important place in have an important increasingly place in daily life. We have progressively introduced some of them in standard medicine. We're beginning with standard with intelligence artificial in medicine, but it's not yet in disaster medicine. For example, for triage, we continuously use some standard paper here, like here on this slide. So the main area for new technology in disaster medicine for victim, we have to we need a new technology for alert, location, severity assessment of triage, identification and traceability of the victim, evacuation, transport, admission. For the crisis management communication, we need new technologies for coordination of relief and care, for mobilization of resources and personnel, for information management, for the instruction to the victims, for example, with dogs, with communication tools, and involvement of rescuer. But this is only two examples of the help of new technology for disaster medicine. So to conclude, we need to integrate innovation in disaster medicine. And thank you again to the project INGENIOUS for providing new help for this important care for victims. Thank you very much.
Thank you, Benoit, for your presentation and for showing us the operations of SAMU, why it's critical to have the technology close with the first responders. So I will continue. I will try to be brief and use only 5 minutes just to present some basic slides and the idea of the concept of INGENIOUS, and then I will give the floor to work package 2, 3, and 4 leaders to provide details for the technologies that we have and some outputs on and achievements that already have during the first rounds of SSDs and lab tests. So INGENIOUS is a consortium with 23 partners from 13 countries. We have 6 end users, first responder teams, 6 SMEs and industries, 1 partner that is expert in legal, privacy, ethical, and social and human security factors, and 10 RTOs and universities. INGENIOUS is developing the next generation integrated toolkit. The toolkit is divided in 3 categories, trying to provide tools for first responders, tools that can support missions and rescue missions in the field, so devices in there in the ground, and a lot of applications that supports the whole ecosystem, and in parallel, one central platform, the Common Operation Picture, that depicts all the information from all the components. So in the first category that we're going to have a short presentation from Eduardo and give more details. We have included in our toolkit solutions such as helmet, uniform, boots, K9 unit, gas sensor. So mainly tools and that are equipped or used so directly by the first responders in the field. In the second category, we have tool that supports the operation in there on the ground, and we have mainly drones, 3 different type of drones. We have the communication that supports all the tools in the field, and after Eduardo, Norma from ITC, Norma Kermer, will provide a sort of overview for this toolkit. Finally, the last group of our tools that we have included AR augmented reality systems, the common operation picture, C2, and other applications such as triage, face recognition, multilingual application, social media. We have a group of applications and platform, and Alexei Zubulaki from Exus will provide a short description for these tools. So into INGENIOUS, we're building the toolkit, the next generation integrated toolkit, and to validate our progress and our work. We have 27 lab tests, 18 small-scale tests, and 2 full-scale exercise. This week we're here at Paris, Samu facilities to have our first full-scale exercise. So we're trying to validate almost in every possible use case or scenario that we have in real life to validate and ensure that our toolkit will be useful for the first responders of the future. Thank you very much. You can follow us in Twitter, LinkedIn, and YouTube, and also at our site you can find our results and all of our activities. Thank you very much.
Okay, good morning. Good morning. My name is Eduardo Arceledillo. I am responsible for the work package 2 leaders. I will present this work package. This is for the smart first respond. Okay. For the smart first responder. This is the contents. First, an overview of the work package, technology, user requirements that we push us, integration testing and field facilities, main findings for testing and achieve results. The objectives are more or less to make your life easier and safer. That's a summary. That's all what we pretend here. The structural roles for the work package is first one initial task to definition of the robustness of the devices, and then for task in parallel. That is currently from the very beginning up to the end. The first one is the helmet, and related with that is the gas sensor. Next is the smart uniform with some electronics and sensor attached to it. Next is the smart boots, and with insoles detecting several activities of the first responders. And finally, the K9 vest in order to complement the activities of this. Starting for the helmet, this is the first prototype. You can see the main technologies should be detachable for using in several regular helmets, and it needs a front and rear module for compact hardware. The replacement batteries is now something that should be increased. In the first multiple operate prototype, we have carried simultaneous video transmissions of up to 2 units, and real time is also achieved. The second one, this one and the next one is are laboratory level is not so close to the real field experience. It has been developed that laser, quantum cascade laser, that in summary, it is needed to produce a laser that could be fine-tuned for an appropriate gas sensing. Within this project, we have decided to to focus on CO and H3. And we have faced several integration issues that have moved to a new design that is currently working on. And this is the new technology developed as well. It's more technical, but it implies an increase. You can increase the size, the sensitivity very high. This could be that only a small amount of gas could be detected in very short time. This is the summary. Next one is the small uniform. You can see the current size of the element. With the main functionality here is to manage the connection between the central unit and several sensors attached to the first responder. It is managed automatically. You don't need to select anything. As soon as you put close together, they recognize themselves and start working. And this information collected is also locally processed in order to reduce the amount of traffic between the local and the final destination. As usual, you ask us miniaturized, rugged, detachable, and also cheap, but other departments. And we have put some effort, a big effort, I would say, in the easy to use. Just a single indicator, good or not good functionality. The smart boots are composed of a pair of insoles with several sensors. In them, you can see some picture here. It is detected some activities like crawling, hanging, and walking. And it's completely autonomous. It stands for long periods, more than one shift, and it's wirelessly rechargeable. One requirements from your side is that it should fit in a regular boot. It's not, you don't have to buy an extra device. The K9 unit is, you can see the picture here, is a vest with a camera with two ranges, visual and thermal. It has also GPS tracking, and it also mounts bidirectional audio for communication between the handler, the dog, and the victim. Okay, and as a outcome, it should be modular because it's more convenient for. Next, I will present some of the user requirements associated with each tool. There is not a complete list, just the most relevant. The helmet should be applied to various helmet types, depending on the agencies. Voice communication should be between various communication devices. This is not completely fulfilled because it's several types of communication and, well, some technical uses. And it requires a device display for infrared video directly. The smart uniform, non-intrusive, detachable. Just when you have to clean your uniform, it should be detachable, easy to use, auto test, configurable, and data retrieval. Configurable depending on the agencies, depending on the first responder role, and so on. And it could be, we have developed let's say a flexible solution that you can put new devices in a simple way. The smart insoles should recognize activity carried by the first responders. We will see some examples compatible with the boots, long operation, and rechargeable battery with And the K9 units, safe and non-intrusive. This is a common for every single tool. Visual and thermal video, not only pictures, but video and voice interaction with handler, block, and victim, and localization as well. As Spiros has mentioned, we have conducted several tests in 2 levels, mainly laboratory test, and that's in our premises, at technical premises, with nearly a pair of components working together. But the SST is the same 2 components, but more integrated with the rest. Here you can see a list of what we have tested in each scenario. I will pass this because I think it's more interesting. Main findings of testing activity. It should seem that is also negative. I highlighted what we have learned within the test. Mainly, those are the main outcomes. Available bandwidth impact helmet video link, as it could be supposed. Helmet modules attached and detached needs improvement as your requirements. The helmet battery should be reconsidered as well, and it should be user-friendly. We have asked several times for that. The laser integration optical feedback issue, as I mentioned previously, we have faced a big problem that we have to move to another direction, and we are close to develop this new technology, but not at a final step of a field used. For the uniform, enclosure needs miniaturization. The picture I've shown is the result of the miniaturization. I think we are not able to reduce anymore. The human interface depends on agencies. We have learned that you don't follow the same procedures. You don't have the same opportunity to put the wearables on. And the data flow is affected by first responder roles. The information the team leader needs is not the information the other person would need, and it should be reflected in the design. For the boots and the insoles, robust recognition of walking, running, crawling, limping, and immobilized events. Long-term operation, considering the field operation, we haven't. Well, it's a good point. We haven't found a relevant packet losses between insoles and uniform. And some improvements that are pending, the insole compartment and the machine models requires high CPU and RAM resources. So we don't have enough space to put everything together up to now. And from the K9, the thermal camera placement is problematic, depending on several what the restrictions. The issues with some feedback when the dog is close to the handle should be addressed as well, because in some cases it needs the dog to be trained to recognize that even you can see the handler and the sound is close to it. And something related with security of the vessel when hitting some obstacles, it should be detachable in a good way. What we have achieved, more or less, I have mentioned, integrated modules, pigtail, that's more or less a repetition. I would escape that. And this is our future work. From the helmet side, smaller, lighter, and software improvement. From the gas sensor, we will move from the nearly lab environment to closer to the field. For the uniform, mainly miniaturization, fitting problems as well, and also integration any other devices, both ad hoc designed or commercial ones. From the boots optimization in the requirements of the machine learning models, increasing the capability of detecting additional activities and some related with mechanical issues. And the K9, the video strength, and also the detachable when hitting obstacles. The main conclusions, we are more or less on track. Our initial assumption was valid, although we have to move with some evolutions. We are right now in the prototype 2 with hardware, software, and inclusions implemented. And we have more or less successfully integration with the INGENIOUS platform, and we have, in my opinion, valuable interaction with you, and in order to catch the results and provide our outcomes. And that's all. If you have any question. Okay, thank you.
Thank you, Eduardo. We're going to continue with Norman Keller from ITC.
Sure. Have to see how the video start if they start automatically. But to sound better, if not, I'll try. Good morning, everyone. So I'll present on behalf of Work Package 3. I'm Norman Carroll, so I represent ITC in the Netherlands. Yeah, I'll try to give you a bit of a rundown on what we have been doing with our drones. Now, most of you guys working in operations, you've seen drones in the sky, you use them frequently, right? But usually just as the sort of eye in the sky, right? You have something that gives you a bit of a bird's eye view of what's going on. In INGENIOUS, we've been focusing on adding value to that information by actually exploiting these data streams, by providing additional information. So that's what I'll be focusing on. So I'll give you a bit of a rundown on what we're trying to do in Work Package 3, the technologies we've been developing, how that squares up in our view with the user requirements, what we've been doing in terms of integrating and testing, and also what comes next. Now, the objective of Work Package 3 really is to develop a set of devices, platforms that can help first responders to work more safely and more efficiently. Yeah, you just heard from Eduardo about all these individual protective features from the boots and the uniforms, etc. But if you have to enter an unknown space, I can only imagine as a non-first responder how sort of like scary that can be. Yeah. So when it's a sort of intimidating site, you have no information about it. It's dark, it's smoky, whatever. So any information that we can help provide, we assume will make your job a little bit more effective, safe, and maybe more enjoyable. So that's what we try to do. So we provide information about the scene. We try to enhance the awareness of the first responders, where they are, where their colleagues are, where they are with respect to hazardous features and so forth. So to try to help you localize yourself in an unknown terrain, both for you to know, for your colleagues to know, for your incident commander to know, yeah, to direct you effectively. Also to know where your assets are. Let's say you bring equipment in, you park it somewhere in the dark, you want to find it back, like an hour later, for example. Right, and then how to communicate all this information, how to optimize this communication effectively. So you've seen our sample site here. So we imagine this to be a somewhat typical deployment site. It's a sort of chaotic place with partly collapsed or destroyed buildings, assets, infrastructure, etc. Yeah, that can be a sort of an explosion, terrorist attack, earthquake, you name it. So we try to work with relatively generic scenarios. So in Work Package 3, we have quite a number of partners involved. Most of you guys have met them. So we have FOI from Sweden, Sinter from Norway, ICCS from Greece. We have DLR from Germany. Again, DLR, they're also for the MAX, and then ITC based in the Netherlands. And you can see that we are working on developing, let's say, quite a large suite of individual elements, largely focused on drones. So we see here at the top, FOI has been working on the so-called MAX drone, and I'll show some illustrations in a moment, something that can enter buildings relatively safe and rugged and provides, let's say, intelligence on indoor spaces. Sinter has been focusing on micro drones, and micro really meaning something like 20 grams, so really very, very, very light drones that can also enter an unknown place. ICC has been focusing on worksite communication, so getting all this information to come together. DLR has two systems. So one is the IPS, so the integrated positioning system. That's the helmet one device that allows the first responder to go through a place and then map it in 3D. And they also have been working on the MAX, so MAX was a CS, a very large drone that can cover very large areas and provide real-time mapping, over the entire area. Now, in our place here, that's probably not necessary, but if you're talking about something like Haiti or something that's really extensive, 10, 20, 30 kilometers, for example, that can easily be covered in real time by the MAX drone. And then we at ITC, we've been working on the ground control station, which is not only the place where all this information comes together, but also where a lot of additional processing is taking place. So for example, the video stream coming from the FOI MAX drone, we exploit that for semantic scene understanding, for example, and to identify victims even in these data. Okay, so that's what we do at ITC. So in a nutshell, most of you who were here yesterday, you've seen the MAX drone already. So it's a small ruggedized prototype drone between 2 and 3 kilograms. So it's relatively portable. You can send it into an unknown environment. You can fly it manually, but it can also fly autonomously. You receive real-time data, so the data being streamed in real time. It can be deployed both outdoors, as you guys typically know, but also indoors, which is sort of more the novelty of the project. It can essentially, it's a bit of a plug and play type system. At least that's sort of the idea. Currently, it contains a laser sensor. If you don't need it, for example, if you say, I got good light, I can use a camera for scene reconstruction, then you can also lease the laser out, for example. So that's the idea, to make it relatively modular. But the upshot is that you can do real-time 3D mapping of indoor places, and then also provides this information for some of the other components. So for example, to guide these small drones as Syntep has been developing. So these are the mints, and you can see already it's an entirely different order of magnitude. So they fit in the palm of your hand. They are much more, I mean, let's say a bit more fragile. You can see that, right? At the same time, you have strength in number. You can just throw in 10 or 20 or so into your environment. If some get lost, potentially, that's also not so dramatic. But the idea is that they get sent into an environment kind of like a daisy chain. So you're setting up a chain of these individual drones, and they set up communication network that then the first responders can refer to. So they act like sort of locational beacons, and that allows the first responders to localize themselves in a GPS denied environment. So the idea is indeed you start at the entrance of a building, for example. You bring in the first drone, and that acts as a beacon and guidance for the second drone, and so forth. So you're building it up as a kind of chain. We can also use the data from the MAX drone from FOI to start with essentially a layout of the room. You can use it to plan where to send these mins to, for example. And then the first responders get a small tag, and they correspond or communicate with the small mints, and thereby determine their position. Communication, again, you've seen it in the field. It's quite a set of kit. This is done by ICCS. It has to be, let's say, ruggedized. It has to be easy to set up. It has to be modular to fit your environment, your broadcasting needs, the distances you need to cover, etc. It combines multiple interfaces for different network connectivity, etc. So it has to be robust. You saw it yesterday. It was pouring cats and dogs, so it has to withstand all of that, of course. So this is what ICCS has been doing. Going back to the tools themselves, DLR, as I said, has two tools. One is the IPS. So essentially, it's a helmet with the instrument on top. And the first responder essentially enters the structure and maps in real time as he or she protrudes through the building on multiple levels, returning, closing loops, etc. And all that should lead to a 3D awareness of the place. So the data are transmitted continuously. You get data in UTM coordinates, so global coordinates. That's also important, directly integrated with the overview map generated by the large drone, by the MAX drone. So essentially, you have a map of your area in real coordinates. You can integrate it with other data sets that you have, and the IPS data get directly referenced to that. Okay, the user not only records continuously the environment, but can also take images. For example, say I see a victim, sorry, Spiro, so I take a photo. That photo gets sent in real time to the incident commander and also geotagged. So the location is also imprinted on that. Yeah, so that's quite good. And what's nice from the data themselves, a point cloud of the, let's say, a 3D point cloud of the space is being calculated. This is a large drone that I mentioned. This is really, let's say, suitable for environments where, let's say, you have large-scale incidents, such as an earthquake, for example, where you need to cover maybe dozens of square kilometers. So you see, this is a much larger device, flies much faster, can fly for up to 2 hours. So you can potentially go 60, 70, 80 kilometers in one direction and still bring it back. So this is entirely a different scale. Has a high resolution camera on it. Nice thing is you don't need an airstrip. It takes off vertically. So you can be in a very confined place. It takes off and then it flies and it returns. Yeah, so you don't need to worry about cluttered environments and so forth. It's very quick to set up. It's all automatic. So you set your course, you set where you want to go, and then it does it automatically. The data also gets streamed in real time and get processed in real time. So this is not something where you need to stare at a screen to see what's going on, but you're actually creating a real-time map, yeah, fully georeferenced. And a few words on what we at IATC have been doing with the ground control station. If you just quickly look at the left-hand side, very often when you're in confined indoor places, you have images that are actually not very useful. They're very dark, they're maybe partly smoky, but usually they're not ideal. At the same time, you want to have some base information. Where's the floor? Where's the walls? How large is the indoor space? How convoluted is it, etc. Right? So that's what we do with the semantic segmentation of low light environments. So essentially taking these poorly lit images and to enhance them in an intelligent way so that they can be automatically interpreted in terms of saying there's a window, there's a door, there's furniture, etc. So it's kind of intelligence we provide there. And with the data that we're getting from the MAX drone, let's say the MAX flies through an indoor environment and you're looking for victims. You're trying to see, are there people, are there victims potentially trapped in rubble? This is what you see on the right-hand side. So we use advanced machine learning to process these images to identify, let's say, body parts, so to speak. Let's say you see that illustrated there, like a hand sticking out. It's a bit hard to see. Now there's some legs sticking out, some hands sticking out, etc. So this is quite challenging from a data processing point of view, because it's quite easy to recognize persons, like entire people with limbs and heads and so forth. But oftentimes you don't have that. You got bits and pieces sticking out, so to speak. Yeah, and that's the focus of the second line of work. Now we, of course, were driven by the user requirements, just like Eduardo explained. The stuff has to be easy to operate. It has to be robust. It has to be weatherproof, like we saw yesterday. It has to be of let's say, sufficient accuracy. So if you want to position yourself, let's say plus minus 100 meters in a building, it's not really going to do you much good. At the same time, you don't need centimeter accuracy either. So somehow it has to really fit your needs. The data collected, they have to be useful. It's not just terabytes of data, but it has to be useful information, right? And it has to, let's say, correspond to your specific requirements, right? And so tomorrow, again, when we demonstrate it, we want to get your specific feedback on how that matches your expectations, yeah, whether you can use it in your work. There are just a few more very short videos just to illustrate it a little bit. So here, this is a MAX flying. This was from Bilbao last year. You see, it's a relatively large drone. So this is not something you carry with you on a day-to-day mission, for example. This is special deployment, obviously. At the same time, it's super easy to set up, takes a few minutes, it's very robust. And you don't need to be standing there. You know, you can actually continue doing your work while this thing maps your entire area. And you can see it covers a very large area. The data are streamed in real time and then processed, and then it lands automatically. So that's very good. And you can see here, this is what you'll be seeing on your screen as a plane, as a UAV flies. You're not only transmitting the data, but you're georeferencing in real time. So by the time the drone lands, you have a complete, accurate map of the entire area, fully georeferenced. Yeah, it's very detailed. You can see that the camera has a very good quality as well. So it's very good. We are using little reference markers. You can see those there. So this is essentially the key to integrate the data from the MAX drone with the indoor deployment. So in other words, the IPS and the MAX, they use also these tags as they go into the building. And that's why the data you're collecting from within the building are directly referenced to this map that's created by the MAX system. This is then the MAX in operation in an indoor environment. Again, obviously you have no GPS information here, so you have to start from the outside with the corresponding tag from the MAX system, and then you go inside, and then you can actually reference these two together. It's a little bit hard to see here now, but you can see as a drone flies through, it uses a camera and also the laser to create a very detailed three-dimensional depiction of the indoor environment. We've done also a lot of testing, and of course, COVID messed it up a little bit, but we were in Bilbao for the SST late last year and tested all of it and saw where our deficiencies are. We met again in Berlin in late March for ELIT and saw a lot of progress, especially on the MIN side. So Sintef had really advanced their work. And so we felt quite ready and prepared to come here. So the work in terms of the research side is now almost finished. We are here now to test it now for the first time, let's say in a quasi-operational real-time setting. It's the first time we're seeing many of you now after 2 years. So we're very excited also to actually put this to work now and see if this, let's say, matches our expectations and your expectations. I'm not sure if this works. This is just a final quick demonstration of the MINs. Yeah, I think you can see them flying here. This is still a little bit concerning if you think of it as sort of like dark, unknown environment, having these tiny drones sitting a bit in your path as you trample along there. So this is still something that also concerns me a little bit. But again, if you are in a large enclosed environment of which you know nothing, and you try to coordinate with your colleagues, and let's say it's dark and smoky, I imagine that to be very difficult if you have no means of coordinating yourself or localizing yourself. Yeah, your incident commander has no idea where you are, you don't know where your buddies are, etc. So if this works, if you can reference yourselves, and you can see then also maybe on the display that we're presenting later on where you are with respect to your colleagues, I think this will be a major improvement. So at least that's the idea. So yeah, we've been testing also today. We will continue to test, and then tomorrow we want to demonstrate it. And then of course we have another SST coming up in September before we then have the final full-scale exercise again in November. I think this is, I'm almost done, Spurs, don't get nervous. This is just an illustration of the kind of 3D information you would get from the IPS or from this helmet-based system. Again, it's pretty rugged, it's pretty crude, but it gives you a very good three-dimensional layout idea of the space that you walked in. Yeah, so this is what we can provide. So our main findings is that also after the testing, the end user involvement, of course, is critical for us. I mean, it's one thing to develop a machine learning routine, but if it doesn't meet your expectations, then, well, obviously, maybe academically that's interesting, but it's not what INGENIOUS is all about. So we need your feedback. Yeah, we need to see if the requirements to meet your needs, the requirements of accuracy, information provision, the kind of categories we provide, if that is what you guys need. Chances are the feedback will be, yes, that's nice, but it's too complicated. Yeah, that's a typical problem in this kind of project. You look at these tools and say, yeah, that looks nice, but I won't be the one doing it because it looks like I need to be sort of an IT person or something like that. So that is something we still need to reconcile. I think some of the tools, such as the MAX drone, it's probably straightforward to use. Some of the other platforms are a little bit more experimental. So yes, that is true. So there needs to be this dialogue. How do we take the next step to make it more practical and more robust and more operationally useful for you guys? Okay. So I think that's pretty much it. Future work, we're nearing the end of the project. The development work as such is done. Now we focus on improved integration of these tools. Yeah, so vis-a-vis the users. And then, yeah, we have these 2 more tests coming up. but the tools for now, they're fully developed. And again, now we want to see how this satisfies the end user requirements. It's not all about testing, dialogue, feedback, etc. So, and yeah, I think that is it. So thank you very much.
Okay, thank you, Norman. So we will continue with Alexia Zuboulaki from Villejust to provide us a short presentation regarding the tools of Work Package 4.
Okay. Okay, so hello everybody. I will be presenting Work Package 4 and the work we have been doing there. My point is not to go through all of the technical details, but give you an overview of the main functionalities and the components we have been developing. The main goal of the Work Package 4 is to enhance situational awareness of the common operational picture and facilitate decision-making during worksite operation through data and information fusion from multiple applications. We have been designing and implementing many different functionalities, which include low and high level data fusion from heterogeneous data sources, model requirements, ontologies, and patterns for capturing information about resources, entities, and their relationships, and augmenting the reality platform to display in a non-intrusive way important information in an augmented reality device. A suite of mobile applications to further worksite procedures and assist cross-team operations, and of course, the COP where all the information is visualized. Work Package 4 is broken down in 5 different tasks, which are led from different partners of the consortium, and each one leads in a tool or the 4th task, which leads to actually a toolkit with many mobile applications, which I will go through each one of them now briefly. So first, for the Work Package 4, we have the Fusion Engine. Now, the Fusion Engine is a backend service that brings everything together. It is the tool that reads the information from all the sensors. It integrates them, it processes them, so as to provide information to COP and to make everything communicate. It involves data ingestion, transformation, storage, and communication. It is the tool that have provided the architecture with which everything communicates. The expert reasoning tool is an application that uses representational analysis and ontologies in order to process the information that are coming from the sensors and to provide some high-level rules that might be useful for you to support decision and understand what's happening in the field. For example, it includes rules to indicate based on first responders' health status and some of the sensors, for example, the boots, whether somebody is immobilized and might need further help. Next, we have the augmented reality kit. Now, the goal of this is to gather information from the sensors and from COP and visualize them in an augmented reality device. Here, of course, it is very important to fulfill the functional requirements because this is a technology to be used in the field. So this has to be non-intrusive. We want a device that doesn't have cables, so it doesn't make your life harder. And of course, we want something that can be manipulated and interacted easily, for example, through simple hand gestures or voice command. Next, we have a set of mobile applications. First of it is the worksite application. Now, for this one, the goal is to help with resource management at the field. It allows It allows you to see what equipment is actually used, who has it on them, the health status of each one of the personnel that it is on the field, and of course some information like the weather, terrain information, popularity density, and this type of information. It also has statistics about the casualties that are currently on the field. The social media app allows to get crowdsourced real-time information that does that through monitoring and collecting tweets. So the application constantly gathers tweets based on keywords that we have collected through your input. So for example, about earthquakes and terrorist attacks. And it also monitors specific accounts, for example, police accounts and fire brigade accounts. It gathers this information, it analyzes them, makes sure that they are relevant to a specific event, and extracts also the location of each one of the tweets. Then the information can be shown, both the tweets, but also the location as in terms of clusters in the COP, but also in a standalone interface. The triage application wants to simplify the triage procedure. It has three main components. I actually don't have a picture here of the triage device. So it is a small wearable triage device. It is a mobile application, and there is also a triage system that sends the information. The device allows to visually show the status of the victim. It has a little LED light that indicates the color yellow, green, and so forth. It has the mobile app that allows to manipulate this device, extract information, and then the system collects this information and communicates them to the COP. Two further applications, the multi-language application. This is a speech-to-speech translation application. The goal is to allow for multiple teams from many different countries to be able to communicate with the command center. Right now, it has implemented French, Swedish, Spanish, and German to English translations. And then we have the face recognition application. The goal of this application is to help you identify victims on the field through face recognition, machine learning process. What is important about this application is that it takes into consideration the field conditions, because usually we do face recognition with just having a person looking straight at the camera, but this one tries to take into consideration low quality image, the conditions of the lighting, and of course, obstruction and changes that might be in the face due, for example, to injuries or debris, and so forth. It allows to upload a specific database of the people that might be missing and then identify them within that database. And of course, last but not least, one of the most important parts of the INGENIOUS toolkit, it is the COP, where all the information is visualized, all the sensors, all the information, the alerts, the events that have been produced from the components are there available for you in order to get the whole picture of the operation. Now, as in all the work packages, we are driven by the requirements. All of the applications and all of the components have the same set of non-functional requirements. So of course, usability, reliability, security are part of everything. And then we have collected for each one of the components a set of different specific user requirements, like the ones I mentioned for the augmented reality device. And each one of them might have something specific. Now, due to COVID, we haven't had the chance. I personally, for example, hadn't met most of the people in real life. We hadn't had the chance to test this in real conditions. We have been through a set of laboratory tests and small-scale tests. This is our first opportunity to bring everything together and test them in real conditions. And then we hope to integrate everything that we're going to get from this experience today and tomorrow and go to the next FSX. Now, in terms of development, we have been on track with what we wanted to achieve in a technical point of view, and we have been meeting the KPIs that we wanted to meet. In the SSTs and the leads that we had done, we have got positive feedback, but of course we get one main complaint, and this is that you want to see them running in real conditions, collecting real-time data, and see how they can actually be helpful. We have submitted 2 deliverables to the European Union to describe our current process. And most of our applications right now, they have a finished prototype, either at the first version or the second version, which we're going to demonstrate during this FSX. Now, there is a lot of things that still need to be doing, and these involve development and refinement of the existing prototypes. Where we need to complete all the use cases that we had originally described. We want to make sure that all of the tools and the applications that I just showed you are seamlessly integrated within the INGENIOUS toolkit. Of course, start and continue testing in real-world conditions. Have a continuous circle of collecting feedback and improving our tools, improve the interfaces, space, feedback in terms of usability, and of course, complete the third version and final version of most of our conclusions is we are really excited to be here and to test our tools. We have been on track, we think, technically, but until you test them and you give us the feedback, we are in the dark. Thank you very much.
Thank you, Alexia. We'll continue with SBFF and Mateus.
Sosnowski. Yes.
Probably this.
Yep.
Wow.
Okay.
There we go.
So once upon a time, there was a group of animals that decided to develop the next generation of toolkits for first responders. So before we get into it, let me introduce you to the INGENIOUS family. So first of all, we have the owls. They are smart thinking academic creatures. So they are the wise ones, and they are they are our academic and research partners. Foxes, they are very cunning, fast on computers. So they are the technical partners that develop the tools. And lastly, but more importantly, we have all the bear family that work on the front line to rescue all the animals no matter size. As you understand, all the bears comes in different sizes and shapes and colors. So we all have similar, but different needs. So with the grant agreement, we had a set of dedicated. And general workshops to elicit the end user requirements and needs. So they were hosted by the snow owl in Greece, Samu in the panda in Paris, and then of course the polar bear in Stockholm. And this was because before the now infamous bat called COVID flew around the world. So a set of 250 something requirements were collected from all the bears. It was high and low, and at times the polar bear was very tired and was willing to give up. But with a little help of the friend, the snow owl from Maria from Greece, we ended up with 85 requirements and needs that were distributed throughout the tools. Most of them were the same or redundant, or we could sort of cluster them. So that's why we have 85 unique requirements. We could now analyze the requirements, and we have the non-functional requirements as a group. And taking one of them as an example, you have the usability. So the tools need to be easy to use with a minimum training. So some of the bears, they are career bears, but most of them are volunteers, or at least do not attend to bigger incidents that much. So having a tool that is very complicated and hard to use, it won't work in the real forest. Then we have safety. So safety always comes first for all the bears. All tools need to be safe to use, in everything from having the clothes snug and tight without the cables hanging loose so you can get entangled, to the predictability of the UAVs that fly autonomously, so we know where it is, so we don't crash into it if we are close to it. Situation awareness. So situation awareness ties to how the system presents the information that is gathered. It needs to be simple, but on target. So all the information from different components should be accessible in the same platform or the same application, but not at the same time, and targeted to the person's needs from his or her perspective and position of command. And careful attention needs to be placed for false positives and false negatives, especially when it comes to decision support on our safety. Power autonomy. This was very hard to sort of quantify because it depends on the definition or sort of on the implementation of the tools. Sometimes it is possible to carry extra batteries, but sometimes we can be off grid without having the spare batteries. So all the tools developed need to consider this and implement all the sort of battery draining implications. They need to be thought of this, so we won't die. The battery won't die on us in the crucial situation. This might seem like a scene from Hogwarts, but it's not. It's ethics and privacy. So ethics and privacy is very important for the bears and the public organizations. It's also very important for the giant octopus, that is the project officers from the EU. Therefore, we also have a whole package dedicated for this, led by the owl Mistal from Triathlon. So how do we test this? So INGENIOUS has set up a lot of different tests, laboratory tests, small-scale tests, and full-scale tests. So taking advantage of the end users training fields, like we have here in Paris, we can simulate realistic environments and get the foxes and to see and understand the challenges that we face. So we at SBFF, we hosted 3 of these SSTs last year. We got to have the end users to work in a collaborative way with the technical partners so that you could actually understand what we're doing. So we have a little film on this. Hopefully it will play or not. Oh. This. No, I had a link. It was working. It was working just a few minutes ago. This is the most important part. It's a link. We can Google it. It's good. Oh, it's not my computer. I would have to get. Where's the access? No.
INGENIOUS is a 3.5-year project funded by the European Union's Horizon 2020 Research and Innovation Program and the Republic of Korea.
INGENIOUS is a project that aims to develop a series of tools and services for the first responders in order to assist them at the field during operations for rescues.
INGENIOUS is developing a next-generation integrated toolkit for collaborative response, which ensures a high level of protection and augmented operational capacity to respond to the disaster scene.
My name is Mateusz Sosnowski. I work as a fire safety and risk management engineer at Södertörn Fire and Rescue. Right here, we will be testing our connected shoe or insole that is pressure sensitive. That provides feedback to our personnel, and we can see the status of them in the field for our safety. So the whole purpose is to be in environments that is as close as possible to destroy buildings, landslides, and earthquake and such.
3 of the small-scale tests were hosted by Södertörn's Fire and Rescue Service and held at the Swedish Civil Contingencies Agency's National Training Site at Revinge in the south of Sweden. The following components were tested, discussed, and successfully evaluated with valuable feedback from the project's first responders. Helmet, augmented reality response platform, real-time language translation app, smart insole for boots, personal area network hub in the uniform, and the common operational picture platform.
The INGENIOUS project has set up a very ambitious plan to incorporate as many tools as possible. So the main benefit of the project is actually to have these tools in a combined system so that everyone can see the same operational pictures.
My name is Tanja Ståhle. I mainly work with project coordination here at MSB, and I'm also coordinating the activities of the MSB real-world testbed. My role this week is to make sure that the MSB real-world testbed users get the most out of their tests and trials, but also to collect experiences, to make continuous improvements to the testbed concept, and of course to be the link to the logistics on site.
The project has been active for 2 years, making great progress on the development of the first and second prototypes of the different tools. All the components are being tested, integrated, and validated with the support of end users in a rich program of 27 laboratory integration and testing sessions, 18 small-scale field tests, and 2 full-scale field validation exercises in total.
My name is Max Ekberg. I'm Associate Director at Södertörns Fire and Rescue Services in Sweden. The use of innovative technologies in our organization provides us with wider possibilities and helps us to be more efficient in the aim to support the public and the society. It is crucial for us that both women and men are represented in the project. We participate with a wide range of competence and experiences to ensure that all aspects are captured.
My name is Eduardo Arceledillo. I work for a technical company as a project manager and also take the role of integration management. This is a small scale integration trade test where components are integrated by pairs. We are using high level facilities, and that allows us to obtain real experience from the end users. This feedback is very valuable for us and would be the input for the next iterations.
What's up, developers? It's Real Tough Candy back online with you guys today, about to pass the mic to my friend Rachel Nicole. Now, Rachel Nicole.
So I want to conclude with 3 sort of key success factors from for these kind of projects from end point of view or end user point of view. So first of all, let the bears be responsible to specify the requirements and needs. Don't be afraid to not fulfill all of them. We are developing prototypes and not a final product. At least what we can do is to see through that we not hinder any crucial requirements by design towards the end. Secondly, bears are family. We like to keep it together. So for us, it has been a success, and for the project, it has been a success to send the same people to all the tests. This way, we know all the ins and outs of the tools throughout the whole project, and we can see the development. And lastly, bears, they like to work out, train, and get smart. So we have access to state-of-the-art training fields. so that the owls and the foxes get the feel of the environment and actually see the challenges for ourselves. By involving end users early in the project, from the beginning and as much as possible, we can identify and correct mistakes, and together we are strong. I think there was time for some discussions. I don't know where we are time-wise.
Yes. I don't know if, okay, so probably they can hear me also at Zoom meeting. So thank you, Mateusz, for your presentation. I don't know if you have any questions from the participants. Okay, maybe we can continue to give the floor to Susanna Sofu from Sideways for a 5-minute presentation, and then we can discuss if we have any question in total for the first presentations. So thank you, Mateusz. I don't know, Susanna, if you can hear us. And, if you
Yes.
are ready.
Hello from Athens. Can you hear me?
Yes, you can hear you. Probably.
Very well. I will try to share my screen then. Is that okay with everyone?
Give us
Can you check, Spiros?
Yes, just give us 1 second because this is the first live, let's say, connection. Okay, you can see, Susanna, your presentation. I don't know if you're using also your camera.
No, I'm not.
Okay.
That's quite all right.
Okay, so I think that we can see your presentation.
Thank you, Spiros. So this is a very brief presentation on the questionnaire that we are conducting on the Ingenious Technologies for First Responders. First of all, let me welcome you to this event. We're excited to have you here. We very much welcome your opinion, your feedback, and there is already a structured way to do this. A brief look at the presentation. We shall discuss the stakeholders leaflet and then the questionnaire itself, the scope of it, and some comments for personal data protection, access, and feedback. So Nadia will be soon sharing the direct link for what we call the stakeholders leaflet. We consider you to be the most important group of stakeholders. With this leaflet, you will see a description of the Ingenious Technologies for First Responders, very brief and concise, the main features, the benefits, the advances for the first responders and the competitive advantage compared to other similar solutions in the market, and of course, contact details of the people in charge. So please take some time to go through this leaflet. It has been designed especially for you. And then the questionnaire itself on the Ingenious Technologies for First Responders. And the direct access link will also be provided to you. Just a few comments on it. This is a short questionnaire that was prepared to capture the first impressions and expectations of the stakeholders. And it's just 7 very short questions. Question 1 should be answered only after what we call the user experience case, so FSX, and it's relative to the performance of the Ingenious solutions. Questions 2 to 7 aim to grasp the expectations, your expectations from using the solutions, the features that the responders would like to change or believe that are missing, the trust, the level of trust in the solution based on the description or the user experience, as well as which alternative solutions that probably using, and if relative, a sort of comparison. Please note that we will not request for, record, store, or process any personal data, and we are right here for any questions and feedback. So please don't hesitate to contact us with any questions or impressions that you have from this. Thank you very much. I think Nadia can now share the link.
Thank you. Okay, thank you, Susanna. Probably Nadia will share in the chat link of the survey. So I can say that the first connection test was successfully done. So I will propose that we can continue with a half an hour break, as we're very earlier than the original agenda. And then we will start earlier with the cluster projects. We're going to start first with Nightingale, as Eleftherios he's preparing to travel, so he will be the first in the list. And after have a short overview, mainly 2 slides per project, with the technology, the main results, we can have a short discussion. Thank you very much. So we'll resume the meeting in half an hour. Δεν έχω κάτι να δείξω. Δεν έχω κάτι να δείξω.
Άνοιξε τη
Την τελευταία, ναι, αλλά... Οκ. Α, εντάξει. Οκ. I don't know if you can hear me.
Yes, we can.
Yes, it is. We can.
Hi. I don't know. Okay. Probably, Eleftherios, you can hear me. Hi. Good morning,
Yeah.
everyone. We are going to resume the workshop, starting with cluster projects with a short presentation, providing some information regarding the technologies and the results that already identified. We're going to have a small deviation according to the schedule. Eleftherios Zounoglu will start with Nightingale, and assistants and Mateos, who will present it, will be in the last point of this slot. So, Eleftherios, maybe you can start sharing your screen.
Yeah, definitely, Spiros, and many thanks. Let me also switch on my camera and try to
We
share
can see
also
you,
my.
yes.
Okay, and probably you should be able to see my presentation now in full screen, right?
Yes, everything is fine. We can hear you and we can see your presentation.
Many thanks, Spiros. Many thanks also to everyone for accepting this small deviation, since I have to catch a flight in some hours from now. I'm Eleftherios Zounoglu from the Institute of Communication and Computer Systems. As we're discussing before today, I'm wearing another costume, the Nightingale's one. In any case, since ICCS and the same research group is also coordinating the INGENIOUS project. I would like also to thank not only the hosts of the exercise, but all the INGENIOUS partners for their efforts for this exercise and the excellent organization, both of the overall demonstration, but also of this workshop, but also all the representatives from the cluster projects, from the DRS 02 topic, that we already have a really close collaboration, proved also recently in the related service events, and we are definitely looking forward to continuing this interaction. I believe also today it's a great opportunity to continue with this and discuss also on common challenges, on similar technologies being developed, trying to identify synergies and try also to identify the best ways to collectively and together demonstrate the work that has been done in our projects, with the overall goal to find the pathway towards the actual use of these solutions. So I will try to briefly present about Nightingale, which the full title is Novel Integrated Toolkit for Enhanced Pre-Hospital Life Support and Triage in Challenging and Large Emergencies. Clearly, it also has as a base some of the developments and the concepts of the INGENIOUS project, but definitely focused on the triage and pre-hospital life support. And this is partially is evident also about the consortium synthesis. The project has been funded in 2020 in a topic related to methods and guidelines for pre-hospital life support and triage. We started back in October 21 with an overall budget around 9 million, and we are 23 partners from 11 member states, including 8 end users and practitioners, 8 specialized SMEs and industries, and 6 RTOs and universities from several countries of Europe and Israel. The overall goal is to develop what we call a novel integrated toolkit for emergency medical response. This toolkit aims to upgrade the pre-hospital triage by creative, innovative technological tools for the medical response. With the objective to optimize both the current procedures and methods, but also the operational capacities of emergency medical services and civil protection agencies, specifically with a clear focus on mass casualty incidents. And why we mention here also the current procedures and methods is because the structure of the project, we have included significant activities involving practitioners and end users on identifying common denominators, best practices, operational procedures that can be harmonized at the European level when it comes to triage and pre-hospital life support. At the end, we plan and we hope that we will offer intelligent, integrated, and interconnected tools and services that will be actually complemented by this agreed operational framework in order to achieve the overall project goal. Few words really quickly about the technologies that are being developed. This includes triage devices and mobile applications. As I said, the work from our side has started in INGENIOUS, but now we are proceeding to improving this solution and adding capabilities for vital sign monitoring. UAV solutions for rapid triaging, counting victims, identifying injuries, and also supporting the triage process. Wide area thermographic scanning, and important information also for the triage process when it comes to hypothermia. Augmented reality solutions to monitor victims regarding their status, their vitals, but also to support the sharing of information and communication between emergency teams and the victims. AI solutions for damage control and classification of medical conditions, trying to compare the vitals of the patient with known signs and measurements, trying to identify any deterioration risk. Also, again, AI applications for optimizing the available resources, assets, vehicles, and capacities. Swap applications mainly dedicated to citizens with online and offline mode, trying to be robust to any disruption of communications. Also with connection with next generation 112 services to support the emergency response and also to support the incident reporting from citizens. Collaborative C3 systems and an incident management system to provide a common operational picture and facilitate the multi-agency and interagency communications. A scenario builder tool to facilitate training, to support training and creation of online scenario that will be useful for training. And as always, an integration environment that will support the interconnection of different tools and the exchange of the information produced by several systems included in the project. Therefore, the expected scientific and technological impact and the innovation potential, as presented, this toolkit is comprising of a multitude of tools, services, and applications that will be complemented by the commonly agreed methods and guidelines to enhance the operational capacity, to respond to mass casualty incidents, and also facilitate the inter and the intra-agency communication and collaboration. And regarding these grid methods and guidelines, as mentioned before, we have included a significant, let's say, part of the project to be dedicated to discussions in a structured way among practitioners, but also a really strong user advisory board with 5 roundtables to produce some clear outcomes when it comes to these agreed methods. Heavy involvement of first responders in the project, also a rich program of training, integration, testing, and validation with tabletop exercises, integration tests, and small-scale tests, and a strong participation of the user advisory board. Several target markets and stakeholders quite similar to those of INGENIOUS, but with a focus on emergency medicine services. What we are now, we have already some workshops on scenarios and use cases, a tabletop exercise based on a simulation system to facilitate the harmonization of technical and practitioners groups and demonstrate some really first prototypes of the systems, and the first roundtable on common denominators. And now we are in the process of developing the technical specification and the architecture. All the information to reach us is here, and thank you very much for your time and accepting this small deviation in the schedule. Thank you very much.
Thank you, Matt. Thank you very much, Eleftherios, for your presentation and representing Nightingale. So we're going to continue with the Cursor project and Tina, and the next one will be Faster and Anastasios Dimitrios to be ready.
I'm ready.
Hi, Tina. Good morning.
Hi. Thank you. Yeah, I can see the screen. Hello, everybody. I'm Tina Ristner from DHW, German Government Agency for Technical Relief. We are coordinating the Cursor project, which I'm very briefly going to present you. Yes, Cursor means coordinated use of miniaturized robotic equipment and advanced sensors for search and rescue operations. Next slide, please. If you can go to the next slide, please.
Yes, I don't know, Nadia is showing the screen. Ah, okay. Nadia, hope that you can hear us.
Yeah, I just continue with my presentation. So basically, what we have the main scope in Cursor project is the safety of first responders and the time needed for detection and localization of the victims. For these two aims, we are developing different solutions with a consortium of 18 partners from all over Europe. And we also have Japan involved in the project consortium, the Hoku University. It is a challenging task. The safety of first responders is a major issue during disasters. And we are, in Cursor project, we are concentrating on earthquake scenario, and we are testing the technologies in the different use cases considering earthquake scenario. And in this case, of course, the time is crucial to detect victims and localize them. And we have different technical solutions which we are developing, some of them from the scratch, some of them are commercially off-the-shelf technologies. We are modifying and adapting them to Cursor purposes. So we have roughly divided the Cursor components here into 5 parts. We have Cursor on the ground. It's called soft miniaturized underground robotic finders, SMERFs. These are the robotic innovation developed in Cursor. And Cursor on the ground is also geophones. Geophones are somewhat more mature solutions. We are improving the filtering system and algorithms from the sensors. Then Cursor on in the air consists of 5 different drone types. They are also we don't develop drones in Cursor project. They are commercially off-the-shelf solutions, and we adapt them for different tasks, but mostly for situation awareness and transport tasks. Then these solutions are supported by communication localization system. intelligence provision for first responders, and decision support system. It's basically situational awareness. All the technologies are integrated with the decision support system, so the first responders are able to make quick and profound decisions based on the intelligence gathered from the field. You can go to the next slide, please.
Just one comment, Tina, sorry for interrupting you. Nadia is changing the slides, but there's a delay, so you can continue and we're going to see the next.
Okay. Okay. So the next slide actually demonstrates the solutions in action, where we want to stress out that you can use Cursor search and rescue system as one toolkit. You can use them all at the same time. You can have drones in the air. You can have at the same time robots crawling under the rubble pile. But you can, of course, use the technologies as a standalone technologies based on the need and requirements on the specific mission. Then, Nantia, you can actually go to the next slide, which is, I hope that it works. These are small video clips from the SMURF tests conducted in Europe and in Japan. I still see the
yes,
Cursor circuit component slide.
Seems that it is freeze because she selected a full-scale presentation, and we're back at slide 4. Maybe Nadia, can you?
Yeah. Now.
Okay.
Yeah. So these small video clips maybe give you an impression where we are at the moment with the SMURF development. This is something that was started from the proof of concept. So we have now 2 versions of the robot developed. On the left side, the black one. Yeah, both are blacks. But on the left side, this is the first version. And on the right side, this is more mature version with monotrack wheels, which have better mobility, but unfortunately also higher price. So together with first responders, we are discussing to find a better solution for the final project outcome. Obviously, first responders are interested to have the best option, but also affordable one. The tests are a continuous process. At the moment, we are in the integration process. We are integrating all the Cursor components in the field. This is a really huge task since we have so many components. But at the same time, we are continuing also testing the single components based on the requirements, based on the issues discovered during the field test. So this is something that we will do until the last day of the project, probably. That's all from me. Very quickly, this is the overview of Cursor project. We have a web page, and I guess later we have some time also to discuss more thoroughly some aspects of the technology developed. Thank you very much for your attention. And thank you, Nantia, for sharing the slides.
Thank you very much, Tina, and for presenting us the Cursor project. I don't know if Anastasios Dibou is ready to continue with faster.
Yes. Let me share my screen.
Okay, we can see you.
Yes, my screen now.
Yes, you can see your presentation in full mode presentation mode.
Great. So, Tasos or Tasos Dimo for most of you, I'm coordinating together with Petros Zaras the FASTIC project. It's a project that started in May 2019 and actually has just finished end of April. We have 23 partners, including a lot of first responders across Europe and in Japan, plus some linked third parties for additional first responders that have supported us during the course of the project. So Faster is creating a tool set that allows first responders to improve their cooperation and their interoperability, to improve situational awareness, risk assessment and anticipation, their overall operational capabilities, communication capabilities, but also to improve the ergonomics of the tools that they are using. And there are three main categories of such tools. They can be split into categories: communication tools, mobiles and wearables, and situational awareness tools. So regarding communication technologies, Faster is working with 5G technologies, has worked actually, and explored what 5G can provide additionally to first responders. It has also worked with UAV-based connection relay, so using autonomous vehicles to relay the connection from a place that is connected to one that is not, but has also worked on the trust of the information being exchanged using blockchain-like technologies to log everything and enhance the trust and information that is being exchanged. There are also some additional non-traditional communication means. One is a haptic communication tool where a smartwatch is used in order to perform predefined gestures that are translated into communication, into some messages to all the other first responders in the area. But also we have an infrastructureless communication platform, which is called Rescue, that can be activated where there is no other communication means in the area, and through Bluetooth technologies, it can transmit information messages to mobile devices in the area. We have also worked a lot with wearables. We have wearables for canines, so for dogs that operate in the area. We have done a lot of work on that, and especially for the use case of searching in rubble, which has some specific requirements. And also we have been working with a smart textile framework that that includes sensors that are integrated in the body of the first responder, but also with external sensors. And all this, of course, is transmitted to the command and control center, together with the location of the first responders. Another field that Faster has done a lot of work is the augmented reality application. We have done work on helping first responders navigating in buildings and in different areas, including getting some the way, the path that the responder should use to reach a victim or some other point of interest, but also we have used augmented reality technologies to control unmanned vehicles and to also stream the feed from them in order to make it more intuitive and to have less equipment required to that first responders have. Yes, hence gestures are used for all this work. In the area of unmanned vehicles, we have worked on a variety of vehicles from UAVs, both off-the-shelf and custom UAVs that can do also some heavy lifting, to different sizes of robots that could either transfer some victims if required, or smaller vehicles that can patrol and map an area inside or outside a building. On top of that, there is some AI-based technologies that are analyzing the scene that is being captured from the unmanned vehicles, semantically analyzing the video feed that we have. Now we are going more towards the command and control center. We have a mission management platform that is based both on the command and control center, but also it is using mobile applications like a chatbot to create and perform missions with first responders, but also with volunteers. And we have also done a smartwatch application that is being used to assign missions and to inform about their completion. So all this information that is being collected from sensors, devices, vehicles, everything is collected in the common operational picture that we have. It also has it has capabilities to control the drones and create some missions for unmanned vehicles. And there are two versions of this common operational picture. One is for outdoors missions, and another one for indoors that can also integrate all the smart sensors that the building may have, and provide them also to the operating officers to improve their response. So all these tools have been used in 3 use cases in Madrid, where we have an earthquake scenario. So we have some collapsed buildings, and we are applying the technologies there. We have an urban flooding scenario that was held in Turin, in Italy, and also an indoor disaster after a terrorist activity that was performed in Kajaani, Finland. So from my side here, you can see the website of the project, and also all the social media of the project. I mentioned that the project has finished end of April, and now we are preparing for the final review of it. However, we are continuing our clustering activities, as Teresa has mentioned, through a series. We are participating after the end of the project to a Horizon Results Booster module together with other projects, and we are open for subsequent operations if this is. That's all from my side. Thank you very much.
Thank you very much, Tassos, for your presentation. We'll continue with Interpret and Rosen Marcel.
Yes. Hi.
Hi.
I share my screen.
I don't know if you are saying something, but
Should be coming.
Okay, yes. Now see your screen.
So, everyone, and thank you for this opportunity to present the Interpret project. So I'm Rosen Marechal, and I'm coordinator of the project for CS Group. So the Interpret project started in September 2020, and the basic objective is inspired by Ridley Scott Prometheus movie. That's to use innovative technologies to help in exploring and understanding the situation. So in this movie, you have a team of UAVs that generate a holographic view of the site. And while we do not aim to have such a setting, we try to get the inspiration. So the project follows a 3-axis approach. First, it's exploring by using cybernetic assistants, that is drones and robots, to explore and to evaluate disaster zones with advanced understanding modules. The second axis is understanding with extended reality modules and also artificial intelligence modules to provide extended situational awareness beyond just viewing things. And the third axis is decision support with intelligent amplification technologies to provide guidance based on doctrines and based on the situation, to also provide alerts and decision support to the first responders. In this case, we have placed operational use at the center of the Interpret platform definition by making sure that it's easy to deploy, scalable and secured, and also to make sure by using a user-centric approach to make sure that the platform improve the speed, the range, and also the safety of the disaster area exploration. So here you have a view of the technologies. So the 3 minutes limits do not allow me to go deep into details into each technology. So basically, you have a ground to front-end approach. So on the ground, you have the cyber physical agents. The cyber agents are drones and UGV. Drones are twofold, indoor drones and outdoor drones for exploring mostly. And robots are leg-wheeled robots that enables exploration even in difficult contexts. Each drones and each robot is equipped with sensors, with cameras and other type of sensors that allow them to really have a 360-degree exploration of the area, not only from the visible point of view, but also from the invisible point of view. In addition to these cyber agents, of course, we take into account the first responder on the ground. So this project is not geared, for instance, to the contrary of others, is not geared toward equipping first responders with technologies. They are, however, equipped with a 3D positioning system, which you can see here, that allows detailed positioning of first responders and other agents on the scene, both indoor and outdoor, and also in harsh situations. So here you have the ground part, and then you have the central part, the core of the system, which is comprised in advanced innovative modules. First, to allow smart navigation within the building, to allow also situational awareness by using the sensors of the cyber agent to assess the environment and to detect elements such as victims, hazard, threats, signs, fires, for instance, and to identify risky areas, so to speak. Also, in this core part, you have the intelligence amplification module, which use all this information gathered from the ground agents and gathered from the situational awareness modules to make sense of the situation and provide recommendation regarding missions to be created or priorities to to make between missions. This intelligence application is also based on a doctrine modeling tool, which do not provide a second aspect of the intelligence by basing this approach on pre-existing doctrines of the first responders. And finally, to support all these modules, you have a set of geodata and model repositories that serve as a brain, so to speak, the system, the memory of the system, and that is improved during the operation and that is enhanced during the operation. Finally, you have the third part of the picture that are the front ends. So you have three types of front ends. First, desktop and mobile front end, but also an augmented reality front end, which again is not used underground, but is rather used in command centers to provide enhanced visualization of the situation by providing a 3D view of the building, 3D view of the area, and to allow better understanding of the situation. All of this is also linked together with a dedicated tactical communication system that is intended to make up for any lack of communication system due to a disaster, for instance. So in addition to this technical approach of the platform, we also have a strong focus on field validation for a complete evaluation of the outcomes. So there is a field validation methodology that is built for the project by paralleling the project from the scenario design up to the demonstration and post-test data analysis. And in addition to the KPI that are planned as in all projects, we also use expected value information by asking the end users what do they expect, and to make precise value as possible from what do they expect and what do they want to see, and then to assess these modules against existing expectation and existing hotspots of any rescue operation. So you can see here the timeline of the field validation methodology that is being used in. Regarding testing and pilots, we have an incremental push to pilots. So the first one occurred very early in the project in November 2021, so 1 year into the project. The idea was to assess the technical choices in an environment that was controlled because it was an indoor situation in Stockholm Metro. The second pilot will happen in October of this year, and this is more a global pilot with assessing multiple risks. So in this situation, it's an explosion at the chemical site. So we will be able to assess fire, smoke, gas, toxic leaks, threats, and also structural damages of buildings. And finally, the third pilot will occur in Madrid in May 2023 by mimicking an explosion in a field building in Madrid. So here we will address unidentified risk and also multiple cooperation with potential malevolent intent. So the main finding currently we are at the middle, roughly at the middle of the project. So I cannot give you a number finding, numerical finding because it's a bit early. For the moment, the main findings have been along this axis. First, about the role and collaboration of cybernetic assistants. And by role, I mean not only what they do, but also what they can collect as information, for instance, or they can support sensors, and what we can do with information that is gathered by cybernetic assistant sensors. Also regarding the indoor and outdoor position intelligence without, and this is very important, using pre-installed infrastructure. So what technologies can bring, and also what kind of method we can use to get a precise indoor positioning of agent. We are also focusing on research on building center operation because Intrepid is by nature building centered. So both from the visualization point of view, of course, but also how we can enrich this building by modeling the difference between a real building and the theoretical initial model of the building, which cannot be the same in the case of a disaster, of course. And also all this building can be used as a starting point for this planning by exploiting issues, windows, doors, and correctly placing threads and obstacles within the buildings. We are also targeted research and evaluation on the use of augmented reality in command centers for operation management, what can it bring and what can be used for, what kind of information is required, etc. And finally, big axis of research is also the use of doctrine models and the use in intelligence simplification. So first, by studying the modeling of operation from a static point of view, we can model the doctrine and the way first responders can think. We try to extract what they think and put it in the graph. It's not easy, many things to do. And also, on the other hand, to integrate to this modeling, static modeling of operation, to integrate learned premises during operation to improve decision making. So making the best of both worlds. So this is the life of the project. We're currently, as I said, in the middle of the project. So we are gearing toward the second pilot for which will enable a life-size test of on the integrated platform. And well, to end this presentation, here are some way to contact us, be informed of further development. Thank you.
Thank you very much, Rosen. So we're going to continue with Pathoser and Dimitris. Yes. I don't know if we can have the microphone. Rosen, can you hear us? Probably see.
Yes.
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 Wait a minute. You have to use the microphone.
Thank you for that. I have a short question. How are you building malevolence into your scenario, please?
We build malevolence by, as part of the doctrine modeling and the intelligence simplification. So this is a kind of uncertainty regarding the threats. This would definitely be the focus of the final version, because yes, it's not something I explained in the presentation, is that each version, each pilot is linked to a version of the platform. So currently we are focusing on, I would say, static threats. So a very physical threat that can be detected by the, for instance, by the cameras. So fire, existence of chemical threats. And then building malevolent, we will build the kind of dynamic uncertainty. So a threat that doesn't have a specific starting point. I mean, for a chemical threat, for instance, you have the fact that there are chemical substances in the area, or that we are in a specific area with where we can detect things. In the case of malevolent, we have elements, for instance, victims, explosion that don't have a certain origin. And this is where the intelligence simplification will be used to help define this origin.
Okay, thank you very much, Rosen. So we'll continue with Pathosen and Dimitris Eliadis, and I will kindly request for the next presenters to, let's say, keep their slots and try to present in 3 up to 5 minutes their projects and the main results, because it seems that probably we're not going to have enough time for the open discussion, but already we are seeing interesting information and common technologies between the cluster projects. So I will give the floor to Dimitris. I don't know if you can hear him, can hear us, or we can see your presentation.
Yes, thanks. Good morning, everybody. My name is Dimitris. I'm the technical coordinator of Pathoser. Pathoser means pathogen contamination, emergency response technologies. We are also in the middle of project. We have a number of partners that are first responders, as well as some technical companies working on sensors, and we also collaborate with Korea. This is led by the GEO Center of Excellence at the University of Cyprus. And the idea here is that first responders, when they operate, they may come in contact with water, of course, and sometimes this water will be infected with pathogens. As a result, people as well as first responders may have dire consequences for both first responders and civilians. Pathogen relies in the middle, let's say, of in the heart of emergency response, smart water systems, and public health. The goal is to design and demonstrate emergency response technologies to address these challenges by developing new sensors, as well as tools for enhancing situational awareness, Moreover, we're designing intelligence and decision-making tools. The goal, of course, is to integrate all of this in a common framework, in the PathOCert framework and platform, and to pilot and demonstrate these technologies in the field, in Limassol, Thessaloniki in Greece, Canada, Amsterdam, Sofia, and Seoul. We try to develop technologies that cover different type of stakeholders during an emergency response, especially when there is pathogen contamination. A lot of actors are involved. In addition to the first responders on the field, or at the crisis headquarters, or at the command control center, we have also the health authorities, the public health and microbiology experts, as well as even the volunteers and the citizens. So we're developing techniques, technologies, methodologies for detecting pathogens, identifying what is the problem, assessing the threat, and then making suggestions for acting. And then after the event, when the event progresses, to investigate in case there are any criminal associations. This is my last slide. So essentially, this is a graphic overview of what PathOCert is all about. We're using satellite images. We're using sensors for rapid testing of pathogens within a few minutes, smart cameras, social media, as well as drones for surveillance, as well as for water quality sampling within lakes, augmented reality for setting up equipment and for better situation awareness, as well as tools for digital twins that we use to simulate and estimate what will happen after contamination event has occurred. So in a nutshell, this is what PathOCert is all about, and thanks for your attention.
Thank you very much, Dimitris, for your presentation and keeping your slot. We're going to continue with Responde and Cleo Varianou.
Yes, hi everyone.
Hi, good morning.
I need to share my screen.
Yes. Yes, we can see the presentation and also we can hear you.
Thanks. So thank you for the invitation. I am here today on behalf of Serides Research Center of European University Cyprus. I will briefly try to present in the 3-minute slot the Responde scope and the developed technology. The project's consortium consists of 34 partners, and Serides UC is actually the leader of the project. So the idea behind the project, fires in summer 2021, illustrate a number of new challenges for first responders. There were increasing demands due to heat stress, prolonged fire periods, mega fires, and increased need for evacuation. So all these are underlying a need for more focused information, feedback from the operations, optimization of performance and coordination. The main aim of the project is to leverage first responders' efficiency and safety by introducing technological and conceptual framework, which is actually focusing on early assessment, safety assessment, risk mitigation, clear common operation picture. And here you can see the main objectives. So the project will provide 5G next generation capabilities to first responders for protecting the public and themselves more efficiently and effectively. One of the main aims of the project is also to design a lightweight wearable chest band and clothing, and I will show you more information later on. 3 sets of sensors will be employed. The health sensor, environmental, and emergency activated sensors. We have several trainings and pilot studies. Responde first training session was successfully held online on December 2020. You can find more information about our trainings. The second training was in Limassol, Cyprus in September 2021. And we have 3 pilot studies, the one in Cyprus, the other one in Greece, and the last one in Spain. I will move on to the details about the wearable sensors, since this is actually the main aim of the event today. There is a very high quality heart rate and breathing activity constantly monitored. Physical signals of the first responders are constantly monitored. The parameters are provided in real time by the system through the data logger. You can see here in the picture, to the control command center. First responders' vital signs are always analyzed to allow prompt reaction and intervention in case of a critical condition. And why we actually need all this, we need to avoid the 2 most common risks for firefighters, the heat stroke and the carbon monoxide poisoning. Here you can see the wearable sensors one by one. Environmental sensors actually measure the air temperature, for example, the beta gamma radiation of the environment, so on. The data logger attached on the jacket receives data from all the sensors. There is a transmission of data through Wi-Fi or the 5G and 4G technology, as I said. And I think this is my last slide. Here you can see our partners, and you can visit our link, follow us on Twitter and LinkedIn. Thank you.
Thank you very much. Thank you very much for your presentation. So we can continue with Respond Drone and Richard. I don't know if you can hear us.
Yes, I think this should be my setup. Hi, good afternoon, everyone, and thank you for inviting us as well for this presentation. I'll keep it short as requested.
Thank you very much.
We actually prepared 2 slides. So Respond Drone is an EU-funded project like all of us here. We're finished. We finished at the end of April this year, a 3-year project that was like Faster is now preparing for its final review, but we're happy to be able to join you here. So I figured let's just keep it at a relatively high level for 3 minutes. That's plenty of detail already. What you see on your right here is a screen of what Respond Drone has done and is continuing to do. And on the left, we have a number of concepts that we are integrating into a single system of systems. So as the name implies, Respond Drone is focused on drones and what they can do. And in our case, it is both making sure you get the data from the drones and the services from the drones that you need in a safe way with as few people operating the drones as possible. So simultaneously operating multiple drones, but also making sure it's done safely. So the drones are actually not flown by people, but by a number of algorithms. And a lot of energy went into automatic flight planning and conflict avoidance. So in that way, in a disaster site, you can have multiple drones flying safely without someone, people that can make mistakes being in control of the individual drones. This leads to a number of drones in the air with different types of what we call payloads. So different types of information gathering, etc. Main ones are obviously cameras. That's a known, very useful payload for drones to get situation awareness from the sky from different angles. And that information is shared directly to both the commander in the field through a web interface, but also to the first responders in the field or sub-commanders, depends on the different levels of operation within first responders. Besides the live video feed, we have a network relay, which is a relay also carried by the same helicopter drones that will relay all the mobile interfaces, all the data from the mobile devices, either through the drones directly to the command post that has an internet connectivity, or relay, for instance, 4G, 5G, or even 3G masts that are further away from the disaster site. This is especially useful in the case of earthquakes or other situations where the communication structure has been disrupted or destroyed, especially in the place where the disaster took place. And if you think about the altitude that drones can fly at, the height that they can fly at, they have a much more direct line of sight to, for instance, 4G towers that are further away, and they can easily relay the communications. This is what we did as well in our final tests that we held in February and March this year in Spain. I'll show you some pictures later. To finish up the different concepts that we used here is that besides the camera and network relay payloads, we also airdropped supplies using parachutes from the different types of drones that we used. And we have a decision support system that was developed specifically here for this. That is a little bit of a plugin, as you could call it, to the rest of the Respondrone platform, because it takes all the data that Respondrone has gathered and then uses that data to help first responders make decisions in the interfaces. Everything here is connected to this pretty cloud. We decided to make it an actual cloud here because everything is connected through different systems working together. And if we move to the final slide with a number of pictures from our final demonstration that we held at the Atlas Flight Test Center in Spain, you see that artificial intelligence algorithms that were running on the drone, on the camera, can spot smoke. This is not photoshopped. This is why it's covering the thickest part of the smoke. Finding people during search and rescue scenarios. You can see here that the drones were flying autonomously, looking for a person here. So the drones were flying autonomously. The sensors were trying their best to find people, and they succeeded. And in this one, you can also see what happens if there's a potential conflict. So the platform here sees that there is a drone already here in the air. So it schedules its own flight path around it, and that's updated 20 times per second. So that even changes in situations will mean that the drones will still be flying safely. In this one, you can see an image of the mobile app. This is the production version where any first responder can take control of the camera by zooming in and out, going left and right, zooming faster or slower. So that means that the first responders on the ground have a direct way of controlling the cameras in the air without having to speak to pilots or payload operators, but being able to directly control it. And this one is a nice overview of the communications payload, and this is one of our more complex missions that we flew, where this arrow that you can see here is the drone. It had the mission to autonomously follow these first responders. So these first responders were in a van going west towards an emergency situation. You see there are other drones in the air. This one was following them with the communications payload, providing continuous internet communications while they were going towards the situation. So they always have the latest information of what's going on. And the squares that you see around it, or the images, are actually mapped and correct visions or views of the coverage. So within the green one, you have 20 megabits of data, 20 megabits per second, and on the outside is the 1 megabit per second, which is still incredibly useful and still enough for video coverage, for instance. And the strange shape that you see is because of the way the payload is set up, and this was completely measured to be realistic. So that's why we don't map circles, because they wouldn't be close to the truth. So this, in a nutshell, is the Respondrone platform. As mentioned, we finished the project, and we are now working towards our final review at the end of the next month. In the meantime, one of our partners, IAI from Israel, are continuing the commercialization of this platform, and they will have a minimum viable product ready by the end of 2022. So that's a good way of these EU-funded projects continuing after their lifespan. And that's it for me. Thank you.
Thank you very much, Richard. I don't have any questions. Also, Nadia, please inform us in case you have any question in the chat. Interrupt us. Okay, thank you very much. So we can continue with search and rescue and Christos Angelidis. Good morning,
Hello.
Christos. Hi.
Good morning. Let me share my screen.
Yes, we can see.
Can you see my screen?
Yes, yes. In
Okay,
presentation.
perfect.
Yes, we can hear you also.
Hello, everyone. Hello, everyone. My name is Christos Angelidis from Connectable Technologies, and I will present the equipment and technologies of the Search and Rescue project. With the Search and Rescue project, we'll design, implement, and test a series of large-scale pilot scenarios. As you can see in the bullet below, there are 7 different use cases. Take as an instance the use case 5, which will take place in La Souterraine training facility in Limoges on 18th of June. The leader of the use case is the PUI France, and the involved partners are Atos, KT, NTUA, and Thalid. In this use case scenario is that the victims are trapped under rambles after an earthquake. For this use case, the technologies that will be used are smart uniform, that the first responder wears this uniform, which includes sensors in order to collect field data, a GPS tracker, which provides the location of the first responders in the field into the main search and rescue platform. The wearable ECG and EMG devices monitor the biomedical parameters of the first responders in the field. The strain sensors, the rescue means which detects anomalies in the environment of the incident. The Concord platform that is the main SNR platform which orchestrates the whole operation. The field sensor device services collecting the field data by time and by range. The situational awareness services that provide alerts and notification to the SNR platform. A short DSS that intends to support the end users regarding the decision making. The physio DSS provides the patient's expected time of death by using vital measurements. Also, in order for this sensor to send data to the SNR Central platform, there are 2 mechanisms: the Apache Kafka in the main as a main integration mechanism. The Apache Kafka gives an event-driven architecture to the project. Also, the data lake ecosystem as the main aggregation mechanism. So in this slide, you can see a list of the other technologies that will be used in the SNR projects, like smart watches, detection algorithms applied on UAV images, rescue system for children, smart glasses, 6-gas monitors, e-learning platform, robots, obstacle detection algorithm, radiation sensors, volunteer application, 3D mixed reality command center, and emergency response health condition monitoring device. To summarize, here is the whole process of an operation within the SNR project. As you can see, when an incident occurs, the command center here receives a call from a caller about the emergency and fills out an incident form through Concord platform. This is mainly the incident management service. After that, the high commander sends dispatch notification to every user and asks for all actors to go to the incident act and further collect data. When the actors arrived on the site, every actor has a specific role, from facing the threat and treating the victims to orchestrating and optimizing the whole incident through the DSS recommendations and situation awareness. At the same time, the SNR technologies are used to help with the operation and collect data and send them to the data lake and the Concord platform. And this concludes all the operation and my presentation. As you can see here, there is the Twitter and the LinkedIn about the search and rescue and the relevant partners here. Thank you very much.
Thank you very much, Jesus, for your presentation and show us the search and rescue project. So we're going to continue with rescuer and Dr. Haralambos Patrikakis.
Thank you. Can you hear me?
Yes, we can hear you. Also can see your camera.
Fine.
Maybe, Christos, you have to stop sharing the screen.
A second. Oh, okay.
Okay, so probably.
Can you see my screen now?
Yes, yes, it's perfect.
Hi, I'm Villejust. I'm professor at the University of West Attica, and I'll be presenting a rescue project in which I'm involved. Rescue is React project under DRS2. It started on the 1st of July 2021 and will be going for 3 years. It's about a 7 million project with 20 partners from now. The project aims to design and develop technology centered around the first responders in order to provide a toolkit that will empower the next generation of FRs, and it focuses on enhancing their operational capacity and safety, focusing on adverse conditions, both environmental and infrastructure-wise. In this concept picture, you can see the different technologies and tools that we will be introducing in the project in order to offer to the first responders sense augmentation, precise and infrastructureless self-positioning, cognitive support, and multi-sense interfaces, augmented reality interfaces, and finally, robust communication among teams, both verbal and data-based. And all this will be complemented with the capability of extracting environment information in situ and infrastructure-wise. This is why you see the black box on the lower left part. So in general, we are working in 4 categories, enhancing the positioning and orientation capabilities of the first responders, providing them augmented tools for enhancing their sensing capabilities, both in terms of vision, of hearing, of touching, of radar sensing, as we will see in the next slide, and improve their communication capabilities, focusing on ad hoc communications, and finally providing them the tools for cognitive load balancing and enhancing their perception. Now, all those tools can be found in this concept picture, where we display the particular technologies and the start and the end TRL level. You see on the left part of the circle all the tools and devices that we will provide the first responders with head mount cameras, hearable devices, HoloLens for AI, smart helmets, and tools for featuring biometric sensors, and also enhancing their capabilities in terms of detecting dangerous gases, having radar sense in difficult environments where there's no visibility. We will also introduce some radars for what we call signs of life detection, detecting if someone is alive near you and you may not hear or see him or her at some level, and we plan to test it even behind walls. Of course, having tactile feedback, and we will also offer what we call the building black box, which will feature building sensors in order to provide to the first responders status of a building, with extra information such as schematics, so that they have a clear idea where will they be operating. As I said, we are giving emphasis on ad hoc communication, and for this we will be using several protocols. We will be using both wired and wireless communication between the sensors and the devices of the first responders, and among the first responders themselves, and of course with the command and control center. Now, as I said, we haven't closed our first year, so all these will start appearing in the next years. We will have also several pilots and tests. We have our website, and we have started our communication and collaboration actions. We participate in the Horizon Results Booster with 2 projects that will be presented after us, from what I see in the schedule. We have in our website the ability to host information from other projects, such as you see the calendar. We have already included today's event. So we welcome information and notifications so that we can include your events. We have our magazine that is tailored mostly to the environment of mobile devices and tablets. And to the right, you see not all, but just a glimpse of all projects related to us, with links to these projects. Your project probably is within the list. With blue, you see 2 actions that we're planning of announcing, some for which you may have already been aware of. Conference on IT technologies for first responders on the World Forum of IoT. The call for papers is ready and will be launched any hour now. And a special issue on IEEE's IT Professional on technologies for first responders. If you want, you can email me, but I will, of course, disseminate this information to all of you. Here is our website where you can get more information for us, and also our social media accounts where you can follow us and get more information. I hope I was within the time limit, so thank you very much.
Thank you very much for your presentation. We will continue with Sixth Sense and Milos Kostik.
Yes, thank you. Can you now I share my screen? We can see this.
Okay. Please try to keep it short.
Yes. So my name is Milos Kostik, and I come from Technalia, Serbia, which is Technalia's technology acceleration office in Serbia. Technalia is a Spanish center. Now we are here to talk about the Sixth Sense project, which is one of the projects in this cluster. And what is it? well, what we are trying to make is a wearable health monitoring system for first responders in hazardous situations that leverages multimodal sensor data and predictive models to allow closed-loop tactile biofeedback about the health status of the first responder. So think about it like this, allowing first responders to actually sense rapid deterioration or risk of rapid deterioration of their health status much before they would be able to do it on their own, because adrenaline training and so on kicks in, and the idea is to make their deployments safer and faster. It also communicates with the center for command, which allows team management. So basically, you could see how let's say how much strain is there on each individual first responder, and with that actually improve the efficacy of the team deployment and hopefully effectiveness and operational safety. Now it is a very transdisciplinary research to develop novel biosensors, novel human-machine interfaces, specifically this electrotactile communication, because we want to use sense of touch to provide this sixth sense. Of course, there is a lot of data analytics and telecommunications involved, because well, we are counting on not always having all the infrastructure present, and safety is a major issue, and we do that with 21 partner from all over the Europe who have specific technical expertise and experience in these fields. And this is all very much centered around our first responder groups. We have the firefighting units, 4 firefighting units and 2 mountain rescue service units who are our main users, and they are the core of our co-development efforts. So we have created the first demonstrator, which looks more or less like this. So integrated in a SmartX garment, we have some novel sensors and electrodes for electrotactile biofeedback. And we have used that in a number of field trials. So first we started with some pilots with separate modules in the mountain rescue scenario back in 1 year ago in March. We tested the electrotactile stimulation. Then we tested the whole system in that summer, which was a first major event during all this COVID issues. So where we were a bit cold in the first one, we were extremely hot in the second one, and we could get a lot of physiological strain measurements there. And then we had some time to think and refine our alpha system, our protocols, and so on, and did another large field trial in the mountain rescue scenario this March. All of that with the alpha demonstrator, and just very shortly after that, we did another trial, but for the beta module for electrotactile stimulation, which, as you can notice, is always the first module that comes to the maturity that can be tested, where we now tested the new electrodes and new protocols developed during the alpha stage or based on the alpha stage results. So over the past year, so this March, we went again back to the mountain to test it in mountain rescue working conditions, both in some daytime activities and nighttime activities, simulating the rescue operation. Well, actually just walking up the hill on a very strong pace, and then doing some other exercises that they found relevant. So what are our results, and let's say focus on the future work. And by the way, you can see that I'm very much focusing this presentation on just these field trials and this part, because of the format. So we have the alpha prototype was made and thoroughly tested both in the lab, as you can see here, and in the fields in both mountain and firefighting scenarios. Beta prototype is currently under development. Some of the modules are already done and could be tested individually. And now we have a few more field trials already in the pipeline, like firefighting scenarios in the late summer. Hopefully, maybe even with some live fire exercises that they do in Slovenia together with the army. Then also in the winter, we will repeat mountain rescue scenarios, but better. And hopefully, we would join the two types of first responders into joint exercise in the spring. Yeah, that would be my presentation for now. Hopefully that is around 3 minutes. Of course, there is much more that we do and that we would like to do. You can see that on the project website. There you can also get our contact info to get in touch. Hopefully we will stop seeing each other like this, well, not seeing each other in online and can start doing some things, well, have some joint meetings. We are hoping to see you all in Brussels in this forum end of June. And finally, get to shake some hands. So that would be all from my presentation.
Thank you very much, Milos, for your presentation. We have 3 more projects, so we can continue with MedFirst MR and Helmut Schrom.
Yes.
Hi, good morning.
So, can you see my slides?
Yes, you can see your screen and also your video.
Yeah. My name is Helmut Schrom-Feiertag, so I'm from the Austrian Institute of Technology, and I'm going to present as a coordinator my project MedFirst MR. So we are dealing with mixed reality, so to provide a new solution for medical first responder training, especially for stressful situation in challenging contexts. So here, a brief overview of the consortium. We are in total 19 partners. We have them from 9 countries, and 8 end users are on board in the project, and also like 3 external advisors. So where we come from is the needs and challenges. So we had recognized so far from other domains like police training, and we're discussing that also with medical training. And the thing is always like they have too less training, or things could also be trained in large field exercises. They are quite extensive, and therefore they need a preparation also for these stressful and complex situations and a solution for that. So, and beside that, it's also then not only training skills, it's also like training resilience in stressful situations. So the idea is behind that the more you are trained, the more are you resilient than in stressful situations. And there were different needs in the training. So it's also not only skill training, it's also like a decision making. It's about situational awareness. If you're the first one arriving, how to communicate with the others, and also like then having a complete scenario that can be trained as realistic as possible. So that means suitable real life trainings are quite resource intensive, and also like thinking on victims, that the injuries are mostly described on the paper, or it's hard work then to provide them the injuries that they look realistic. So, and on the other side, current virtual reality trainings are only virtual, so you don't have to anything you can touch, you can do anything with that. So our focus was like providing a realistic scenario, but doing also like hands-on experience on medical assessment or medical treatment. And there we came up with a mixed realities training solution approach. So to provide then this virtual environment with a context simulation, like earthquake or landslide or something like this, or traffic accidents, so mass casualty incidents, to give them the experience and have them in there. Mannequins, they are then can be used for the medical treatments. And we will also provide sensorical input. That means also like sound, but also like smell and other olfactory senses. For better gain an insight about the training and if people are at the stress. So what means stressful situation? So the thing is like, what we want to come up is like to provide a smart wearable so they are wearing. We heard already a lot of that. Also in Sixth Sense, providing sensors to measure physical exhaustion. So in our sense, we are focusing on psychological stress, more on that. So if the situation is challenging to them, and then we want to provide a smart scenario control based on these measurements and the behavior of the trainees to adapt the training to their needs. So if it's too much stress or it's too low, and so then the scenario can be adapted on that. And the big advantage in VR is like everything is recorded, so we can provide a real good debriefing analysis. So after the training, and so that deepens the learning then inside. And also one outcome will be the guidelines in the training framework. So what is needed to include this solution in a training institute or in education. So to give an overview how that training approach will look like. So you will have, as everybody knows, a virtual reality environment where people have their head-mounted devices put on and going through the scene. So in our case, we will go up to 4 people at the same time. So from hardware resources, so it's quite expensive to provide more than 4. So at the beginning, so as proof of concept, and therefore what we understand from mixed reality is like we are aiming in that augmented virtuality part of mixed reality. That means everything you see is digital, but behind different digital avatars, so there is then a mannequin behind that can be touched and handled and treated as required. And also like they are equipped with these wearables, they are continuously transfer the measurements, and the trainer will have a real-time dashboard, so where he can have look at the conditions of the different trainees and can then interact also like as a control instance then to the scenario. And this, it can be done manually, or what we want to come up is also like a little bit AI smart control. So we are investigating in that how that could be then introduced, like is the AI do everything, or is it like more it gives recommendation. And at the end with the debriefing, so every motion, so the people are equipped with a full body tracking. So every motion is recorded in that, the biosignals are recorded, the actions, and also like the mannequin, behind the mannequin, there is a medical simulation. It's quite a high fidelity mannequin, so that all the signals, all the treatments, and all the keys of the vital signs so of the patient are recorded and can be analyzed in the debriefing. And what we know so far from training is then it focuses on that the things they were good and bad, and it ends the discussion if something was done or experienced other. So now you have the proof how it has be executed, and that's then focuses on the discussion on the medical part. So here a brief overview on the medical technical solution. So we have a VR system from Refence, our partner. It's a multi-user VR training. Normally they have up to 10 users in there. Then for the visualization, we have a partner that will provide the 3D content, also like the realistic impression of the avatars and the injuries. We have a partner that is developing mannequins, D2D, so that is also used for normal mannequin training. So these mannequins are highly sophisticated. They can blink with the eyes, they can change the skin colors already in reality, or start bleeding. we have one partner that will provide the technology for the smart wearables. So we want to also come up with a smart wearable that is easy to apply and gives reliable information about the vital signs. And for the data integration behind that is the Spanish partner IDENA. So the advantages are on one view. So for the training, here's active learning. So it's not this common front desk learning. It's like he's engaged, he's immersed in the situation, and he can learn to cope with this stressful situation. For the trainer, it's easy. Then he has the complete control of the scenario. He can provide the same conditions for all of the participants, and it's one-click repeatable. So that means if you have something done wrong, or you have to rethink or apply a new strategy in a mass casualty incident scenario, then you can do a debriefing and go back to the scenario and can do it again, and can have a look if that works out better, what you now learned in the debriefing. And also, like for the policymakers, it's something like what they always want to hear is like resource saving, but that's what the solution can provide. So already if you share then scenarios with others and users, so and then it's easy then to create and share scenarios, training scenarios with different end responders from different countries. So that was from my side. So there's also a slide then so with the contact details and where you can get some more information about it.
Thank you very much, Kieran, for your presentation. Also, Richard, for your participation. We're going to continue with Timmy Aguirre and Kaglar Akman. So I can request Kaglar to stay in a short presentation. And the last project will be assistance, and Mateus will provide this presentation. I don't know who have Kaglar Akman with us.
I'm here. Can you hear me?
Yes, we can hear you. Also,
okay, I'm sharing my screen.
Okay, yes. Yes.
Can you see my screen?
Yes, your desktop.
Good. Okay, let me start. First of all, I'd like to thank INGENIOUS team for the invitation to give us opportunity to attend this workshop. I believe it will be very fruitful for everyone. My name is Çağlar Akman from Havelsan in Turkey, and I'm the technical coordinator who is coordinating Team Aware project with Monica from Simavi in Romania. I have 3 minutes, I know, and I'll try to fit this time slot. Our Team Aware project started in May 2021, and 1 year has already passed. We have 2 years more to go. The Team Aware solution corresponds to a situational awareness system for the first responder teams, which is enhanced with artificial intelligence and augmented reality. As we all know that first responders are the critical groups who have the emergency zone at first for rescue operations. So it is understandable that they need high-tech situational awareness systems, which can be used not only in team, but also for the detection of surrounding risks and events.
Can you please explain in Chinese?
Providing an integrated and cost-efficient situational awareness system with heterogeneous and interoperable sensor units, varying from drone-mounted systems to wearable and external sensor systems. And we also would like to provide highly standards AR and mobile human-machine interfaces that can be easily used by the first responders. Okay, you see our consortium map, and here is the list. We have 24 partners from 13 different countries. We have 16 technical partners, 1 ethics partner, and 1 advisor network partner with 6 end users. We believe that we are so lucky since we have active and also proactive end users besides our technical partners in our consortium, so that we can define what to develop more realistic.
Sorry for
No.
interrupting you, because I just saw that you have 29 slides, if I'm correct. So I can't.
No, I don't have 29
Yes,
slides.
I think
Okay.
that's a bit
It's a
much.
typo, I think.
Okay.
It is no. Okay.
Okay.
Okay. Now I'd like to switch to more technical solution part. Okay. I think you are afraid of the fact that I
Okay,
have
so
29
please
slides.
keep
No.
it short. Yes. Okay. Thank you very much.
It's really hard also for me to present in 29 slides. Okay, now let me switch to our technical solution part. Okay, the proposed solution, our proposed solution is based on the capability gaps listed by IFAFRI, the International Forum to Advance First Responder Innovation. Gap 1.
No, I
let me
don't think
summarize
that is correct,
Gap
my
1,
friend.
proximity of first responders
You
to
fucking
risks and
nikker.
hazards. Gap 2.
You're a
Detection
nikker.
and monitoring
You're a
of
nikker.
surrounding passive and active threats
Kill yourself.
and hazards in real time. Gap 3, identification of hazardous agents and contaminants. Gap 4, the ability to detect non-traditional sources. In the right-hand side, you see infographic system diagram, block diagram, and you also see the color codes. We first defined our events, risks, and threats corresponding to these gaps. And then we decided to develop our corresponding subsystems which can detect or which can monitor such events or risks. Okay. For example, passive and active threats. We defined victim detection, fire or smoke detection, infrastructure monitoring, any crack on our buildings. Okay. And chemical hazardous around the team, first responders team. So we have such systems, head-mounted cam. I will pass the details in the next slide. So I will give the brief here. Here you see our subsystems corresponding to our events. For example, there should be multiple and non-traditional source management in first responder operations. So we also involve social awareness. We call it social awareness, and we involve social data from the social media. We call it citizen involvement and social media and data. Of course, we will establish a secure cloud communication network to collect the information and data gathered from each subsystem to build a common operational picture for the first responders in the operations center as well as in the field for the first responders via augmented reality interfaces. Okay. Here you see another infograph. Here is the first responder carrying our wearables and operational drones for different operation reasons, aims, objectives. And the first responder in the field will be able to see, we will be able to obtain the situational awareness via augmented reality interface. At the same time, the operation leader will be able to see and monitor and track the whole operation from a remote operation center. Here are the list of our systems. First of all, we have visual scene analyzer system for victim detection, fire and smoke detection, and indoor guidance of the first responders to exit in a safe net. Then the second system is infrastructure monitoring systems for damage detection in infrastructures during any natural disaster. Our next system is chemical detection system. It is used to detect hazardous gases such as ammonia, sulfur dioxide, and so on. And we also provide a chemical dispersion model, which provides the dispersion information from the source of the chemical to a zone to another location, to another place in a given time. And we have acoustic detection system to detect gunshots and explosions, and human voices. It is another important feature because during the disasters, during the rescue operations, we need to hear human voices. We have team monitoring system to monitor activity and health, and at the same time, indoor and outdoor location information of the first responders in the field. We have finally citizen involvement and integration systems to integrate our systems with social media so that the citizen will be able to provide information via social media. And of course, we have secure cloud communication, and we fuse all the information coming from these subsystems in team-aware software platform with fusion algorithms and AI algorithms, and then we will present a refined information to the first responder in the field via AR interface and the operation leader in the remote operation center. We will have 2 demonstrations. One will be in Turkey and the other will be in Romania. The scenario of the demonstration in Turkey will be natural disaster. There will be there is an earthquake and fire in Bursa Salbey in Turkey, and we will run our systems and we will see our performance. Then there will be a human-made disaster scenario in Romania. It will be a kind of terrorist attack in Bucharest, and we will see again our system performance in case of such scenario. Now, what we have done so far, and what will we do in our team-aware project? I would like to talk about this. As I told you before,
wait, can you go to the previous page? 1 second.
To go. We finished to analyze our use cases and scenarios, and we have already defined our system requirements for each subsystems.
Sorry
now,
for interrupting you again. I will kindly request if it is possible to conclude in 1 or 2 minutes and continue with the next presentation.
Thank you for Thank you for sensitivity. I think I will be finishing. Okay.
Thank you very much.
Damn,
yes,
boy.
As the other presenters did. And then we will be in the subsystem development and interim demonstration phase. In our interim demonstration, we will check what we have done so far to define the next period. Okay, thank you.
Thank you very much for your presentation. So we're going to continue with Mateus and the last presentation, and I will need then some minutes just to recap and share 1 or 2 questions to the participants.
So yeah. So we as the SPFF, we have the pleasure to be sort of in two projects that are quite similar. And one of the main benefits that we sort of conclusions from my last talk is that we are actually sending the same people to both tests. So we can draw conclusions and sort of experience from both of them. Assistance is of course a 2020 program. The timeline is started in 2019. It will finish during the summer. We have 8 countries and 19 participants throughout Europe. So the assistance trying to we're developing a new platform for situation awareness that includes integration of the UAV, robots, and drones and adding some innovative modules such as visualization module, drone mission module, and so on. We also have sensors mounted on the platforms, on the unmounted platforms, and then integrated also in the wearable equipment on the first responders. On this, we're also developing a robust ad hoc network for drones to sustain and keep ensuring the platform's connectivity to having to internet, basically. The second part of the project also addresses virtual reality training. So we have 3 different modules, both VR, AR, and MR, that we can train along with the curriculum tailored to the needs for each first responders, and also to work together and train together, because we are not alone on a bigger disaster scene. So for this testing, we have 3 pilots. I will skip this one. The first pilot was in Izmir, hosted by ambulance organization in Turkey. The second pilot was a few weeks ago in Rotterdam. It was a chemical disaster. And the last one, I don't have any pictures because it will be in 2 weeks in Spain, and that's a terrorist attack. So yeah, that's it for assistance. So Spiros. I have the advantage not knowing all the details, so that's why I could keep it short.
Okay, thank you very much, Mateusz, for your presentation. I would like to thanks all the participants of this workshop that have joined in this meeting, and also through the link and let's say that the hybrid meeting that we had today. Also, I would like to thanks all the projects from the cluster providing their solutions. It really very nice aiming all of this group of projects to provide, let's say, similar solutions aiming to help first responders, ensure their safety, reduce time of the mission of the operation. For sure, it is critical to let's say use all these projects open source solutions that will guarantee to continue the maintenance and the usage of the platforms and the solutions after the end of the project. And of course, it is also crucial to follow standards while developing our solutions. And
Sam je rekao da mogu od sutra pa nadalje, mislim, nema ove adrese. To sam napomenuo od sutra. Mislim, možda mogu
in regards also to the data models and the communications, it will be easy for, let's say, add more sensors, more devices, more solutions, more technologies, easier in case we're developing according to the standards and to let's say global data models for a future improvement of the toolkits. So I would like to let's say only 2 questions due to already have extend our slot. So I will ask Mateusz as first responders participating, and I mean Mateusz SBFF participating both in INGENIOUS and also assistance as first responders, and actively contribute to the requirements and host and also participate in a small scale in full scale demonstration. What lessons and experience have you gained so far from the testing activities that you participate?
So, well, the experience is to actually meet all the people and work together. So testing the equipment and the things that we're developing is one part, but also to actually be on site and talk to developers, talk to other first responders. We actually discovered that we do the same things differently, but we can work together no matter what. So it's quite fast. We know how to work together. That's one of my main benefit. And for assistance, it's a 3-stage 3 tests, and they started off by testing in small scale, sort of testing, and then we went up to a bigger scale test for a bigger exercise, and then hopefully the whole system will sort of be tested in a few weeks. The problem was that we are not, even though we are in the developing phase, so the equipment is not really mature to actually test in a full scale and sort of real life scenario. So we have to sort of be aware of that when we were testing. So hopefully we can learn from that for future tests and how to tailor the tests for testing the equipment, not actually using the equipment as in a real scenario. So that's our sort of experience from the tests.
Thank you very much, Mateusz, sharing the view of the first responders in this, let's say, 2 cluster projects. So I will share one last question with Anastasios, Dimos, and Faster, as Faster already, I don't remember, 1 or 2 months ago, finished. So let's say maybe Tassos can help us and answer what have been the main achievements and findings of the testing activities of Faster.
Yes, sure. So Faster, I think that it's one of the few projects that actually decided to live with COVID and to not request an extension. Despite this fact, our project officer has urged us to really improve all our testing or our testing procedure despite the situation with COVID. So the consortium responded to this after the first review, and we have actually extended our testing planning. We have included several new locations that were not in the grant agreement, and we have also made more iterations in existing pilots, even if this would mean that they would be in a smaller scale. What we did, and actually we were a bit lucky about this, is that we always had a technical partner that was leading the activity, and then we had local first responders that had the opportunity to have some hands-on experience. So this is something that that shaped a lot the development, because it allowed us to make more iterations even than what was expected and written in the grant agreement. And this, in the end, it served us very well, because we had a successful last pilot where everything worked, and it worked in the together with an exercise from the first responders from several countries that collaborated to perform. So this was something that we are really proud. One thing that one experience that I would like to share with the rest of the projects, especially regarding the last pilot, is that the nature of the work of the first responders is such that creating an exercise and providing people the opportunity to have hands-on experience are two things that are not very compatible. So I would urge everybody to create different sessions where probably different days also, where first responders will have the opportunity to test the tools in their own pace, and separate pilot days for exercise like piloting activities, because during an exercise, especially when a lot of people are involved, it's not easy for the first responders to really get in touch with the tools. For example, in our end pilot, we had more than 120 people that were trying to coordinate and to intervene in different points of the scenario. And for many of them, this was a factor that didn't help them to get as much contact and hands-on experience as some of them would like.
Thank you very much, Tassos, for your reply and also for your recommendations, as tomorrow we're going to have the first full-scale exercise. And well, thank you everyone for your participation. We're going to have the second workshop during November 22, the same week with the second full-scale exercise and the final. And we'll be happy to have all the cluster projects with a bigger slot and an open discussion to, let's say, provide and share the updates regarding the results. Bye-bye, everyone. Have a nice day.
Bye.
Thank you. Have a nice day.
Bye-bye.
Goodbye.
Thank you.